All right, problem number 2. We have a marble and a cube at the top of a ramp. They start from rest and roll down. The marble rolls and the cube slides, but no friction. Determine the ratio of the speeds, and it just talks about the center of mass, but we're just looking at comparing their linear speeds. So all we're doing is we're comparing both of these. So I have a marble or a sphere which has I equals 2/5 mr squared. Now that one has friction, to a box with 0 friction, doing their speed at the bottom. Okay? Now we could do forces, but the easier method, once you have a change in height, is going to be energy, especially if you don't have friction, like this bottom example, and the top one we said rolling friction does 0 work. So I would start with energy at 1 plus work non-conservative equals energy at 2. At the top, I have potential energy, which I'm going to label as mgh, plus work non-conservative, we said rolling friction does none, equals, at the bottom, I have linear kinetic energy, but I also have rotational kinetic energy. If I look at the bottom one down here, it has potential energy, and at the bottom, it only has kinetic energy. So all of this gets converted to linear kinetic energy. On this one, some of the energy goes here and some of the energy goes here. So you should already know that the box has to win. The box must have a greater velocity because it has greater linear kinetic energy. It doesn't have to produce any rotational energy. And that's actually what friction does. Friction's slowing it down, but instead of doing non-conservative work, friction is just converting the energy to rotational kinetic energy. So you already should know that the non-rolling object is going to win. Yeah, what's that? All right, let's solve the bottom one. That one's the easier one first. Right? So looking at this bottom one, let's solve for velocity in terms of h. Well, I see here mass cancels. That's great. So I'm left with velocity equals 2gh and square root. So that's that one. Let's go up and do this other one. Let me clean this up just a little bit. So the issue we've seen is we got to get everything either all linear or all rotational. So we already have, we're looking for velocities. We'll compare. So it's going to be 1/2 2/5 mr squared. We said omega times r equals v, so omega equals v over r, plugging that in here for omega, so v over r, and omega is squared, so I have to square this, so this r squared cancels that r squared, so I end up, for this problem, having 1/2 mv squared plus 2/10 mv squared equals mgh. Masses all cancel. Now I have to do a little bit of adding fractions. Lowest common denominator. So this is going to be 10/5 for 1/2. So I have 7/10 v squared equals gh. Doing some algebra, I get 10/7 gh, and I have the square root of 10/7 gh. From this, the problem, I believe, asked for the ratio. So the ratio they're looking for, they said cube to marble. So cube over marble. So the cube equals the square root of 2gh over the marble, which is the square root of 10/7 gh. Well, when you divide by the same thing, those cancel out because they're equal to 1. So I have to do 2 divided by 7/10, but it's still the square root of that. Well, anytime you divide by a fraction, so that would be the same as inverting and multiply. So 2 divided by 10/7 is the same as 2 times 7/10. So this would end up giving me 2 times 7 is 14 over 10, but I still have my square root. So that is our ratio. You can check your answer, and there you go.